And welcome back. My apologies, I have to stick to the 15-minute window for all the YouTube videos, so I can only do 15 minutes at a time, so my apologies with that. Now, we were trying to find that probability that the first candidate selected had a bachelor's degree and the second had a master's degree. So once we're able to go through the whole calculations, we'll be able to see that 35 times 15 all divided by 50 times 49 should get us a probability that will be approximated by 0.214. Now, the next question says, what is a probability if replacement was allowed? So meaning that we took one of the candidates that had a master's degree, all right, and the second candidate also had a master's degree, or vice versa, right? So we want to look at this probability now. Probability first had a bachelor's and second has a master's, but we're doing this with replacement. So the first probability stays exactly the same. That's going to be 35 out of 50. However, when we're looking at the master's degree, or the people that have the master's degree, that's going to be 50 out of, still in this case 50, because we are allowed to replace the candidate that we removed. This probability comes out to be 0.210. Now, one of the items that I want you to look at here is looking at these two items, or looking at part A and part B, notice that their probabilities are almost identical. And that's not really a coincidence where these two are identical. The reason being is because what we're going to talk about next, that we have this 5% guideline for cumbersome calculations. Now, cumbersome, that just means very difficult. All right, so tedious, difficult, anything like that, synonymous to cumbersome. So here we go. If a sample size is no more than 5% of the size of the population, treat the selection as being independent. Now, as we look at the selections above, right, or the process that we worked with above, for part A, we said that the probabilities were dependent. But look at part B. Can we establish that these probabilities are independent? And we sure can, because one probability does not affect the other because of the replacement. Now, looking at this, we're going to say, okay, well, yeah, the probabilities aren't too off, therefore we can use one to approximate the other. The easiest way to do this is if we treat them as both being independent. In other words, we're not going to be looking to account for the change that took place in that denominator. All right, so here we go. This example, we're going to say that a quality, whoa, and it did it again. Wow. My apologies. Whoa, here we go. My apologies with this. It's a new software that I'm using, and I hope to have everything ironed out and ready to go within the next few days, but cheese and crackers. Here we go. Okay, is that good? Is that good? Yay. And it's gone. There it is. All right, let's get this a little bit larger. There we are. And let's see, is it going to move on me? Boom, just a little bit, but it's okay. Awesome. All right. You know what? I think I'll take it right now. So here we go. So for this example, we're going to go through and we're going to identify that, or this example is going to say that a quality control analyst randomly selects 3 different car ignition systems from a manufacturing process that has just produced 200 systems, including 5 that are defective. All right, so we want to now look at this. What is the probability that all 3 ignition systems are good? So the probability that all 3 are good. All right, so we're going to go through and we're going to see how many are good. All right, so it only says that 5 are defective. If only 5 are defective, then we would do 200 minus 5. That means that 195 are good. So this is going to be 195 out of the initial 200, but we have to select 3 of them. So the second one is going to be 194 out of, well, we already chose the first one, so we take this out, choosing the next one, 193 out of 198. Once we've selected all 3, like we just did, we go ahead and we count this probability, or we multiply to find this probability to be about 0.926. Now, this is under the assumption that we are working with that these events are dependent. Now, for the next part, for part B, we're going to say use the 5% guideline, and we're going to treat these as independent. So let's see how we can treat these as independent. So the probability that all 3 of them are good is going to be 195 out of 200. Once again, 195 out of 200. The previous probability does not affect it. Once again, 195 out of 200. The previous probability does not affect it. This means that we're looking at 0.927. Now look at the 2 probabilities here. Are these 2 probabilities almost identical? Yeah, they're almost identical to one another. Which means, could we have treated this as independent from the very start? The answer is yes. We could have done that simply by looking at the sample. The sample was only 3 ignitions out of the initial 200. 3 out of 200. If you take some time and if you put that into your calculator, 3 out of 200, you're going to get something that looks like 0.015. In other words, this is 1.5%. Analyzing what the cumbersome calculation guideline is, cumbersome calculation says that it must be less than 5%. And it in fact is. Therefore, we could have treated this as independent events. Awesome. So, that now concludes section 4.2. So, the next video that I will be making will be a section 4.3. All right, and I will see you all then.